Hey, good morning. Let's continue our lesson. So last time we studied length and dot product, right? And then distance between two vectors or two points. Let me remind you about that before we move forward. Okay. So for vector u, u1, u2, and un, we define the norm or the length of u, that is square root of u1 square plus u2 square and so on plus un square. Okay, and for if we have another vector v1, v2, vn, so we can define the distance between u and v. So I write the distance between u and v, that is just square root of u1 minus v1 square plus u2 minus v2 square plus so on plus un minus vn square. So that is the distance between u and v. And today we will study how to determine the angle between two vectors. Okay, the angle between u and v. All right. Let me remind you about the cosine law, or the law of cosines. Okay, from maybe from high school or from pre-calculus. Let's say law of cosine. So the law of cosine says if you have two vectors, right? Here is the origin, here is the u, here is the v. So you can determine the angle between u and v, right? And here is norm of u minus v, okay? And then here is the norm of v, and this is the norm of u. So in this triangle, we have the following law. U minus v square equal to the norm or the distance or the length of u square plus the length of v square minus 2, the length of u, the length of v, and then cosine of theta, where theta is the angle between u and v. So from here, you can get cosine of theta equal to, I would write like this, the norm of u square minus plus the norm of v square minus the norm of u minus v square over 2 times of u v norms, right? And you know, since we have the formula right here, the norm of u, the norm of v can be determined similarly, and the distance between u and v. So you know, when we open all this, we will get, actually that is just u1 v1 plus u2 v2 plus so on plus un vn divided by the norm of u and the norm of v. Here, that is nothing but the dot product between u and v. So I can write cosine of theta equal to dot product of u and v divided by the norm of u times the norm of v. And that is the formula which help us to, you know, to determine the angle between two vectors. Okay, so let's consider the following example. Like we have u equal to 1, 2, 0, and -3, and v we have 3, -2, 4, and 2. So we can determine dot product of u and v. You have 1 times 3 plus 2 times -2 plus 0 times 4 plus -3 times 2. So you get, here's 3 minus 4 is -1. This one is 0. So, okay, let me write this down, right? 3 plus -4 plus 0 minus 6. So basically you get -7, right? You get -7. And from here, you can find cosine of theta equal to dot product is -7 over norm of u. So I still need to find the norm of u. which is 1 square plus 2 square plus 0 square plus 93 square, okay, times square root of 3 square plus 92 square plus 4 square plus 2 square. And then you get -7 on the top. And here square root, let's say 9 plus 1 is 10, 10 square root of 14 for the first one, and the second one is 9, 9 with 4 is 13, 13 with 20 is 33. So that is the cosine of theta. From now you apply a cosine, you can get the angle theta. A cosine of -7 over square root of 14 times square root of 33. And you can use calculator to determine the angle. Okay, so you know that is how we can find the angle between two vectors, right? You know, this is very very important. You know, if you already took calculus 3, so you know you already know how to find this, because in calculus 3 we already learned this. And from this formula, let me repeat the formula again, right? Cosine of theta, that is u times v over norm of u times norm of v. So what happens if cosine is equal to 0? If cosine is equal to 0, so we get cosine of theta is 0. That means theta is equal to pi over 2. So when theta is equal to pi over 2, we have the following picture. That is u, that is v, and this is the angle pi over 2. That means v and u are perpendicular, right? V and u are perpendicular, so I write like this. In this situation, we have u perpendicular to the v, or we say they are orthogonal, right? Orthogonal. This is very important, you know, from very simple formula. So now we can determine not only the distance between two vectors, we can determine the angle between them, and we can determine orthogonality of vectors. So basically, the cosine is equal to 0. Look at this. The cosine is equal to 0. So the top should be 0. You see that? So the top should be equal to 0. That means, you know, dot product is just 0. So two vectors are orthogonal if and only if their dot product is equal to 0. All right. Let's consider the following example. So like we have u equal to 1, 0, 0, and v is equal to 0, 1, 0. So I hope you could recognize these two vectors, right? They are two vectors in the standard basics of R3. Standard basics. So it's obvious that dot product of u and v is 0. That means u is orthogonal to v, right? And we can see in the picture 1, 0, 0 look like this. Suppose this is 1, this is x, this is 1, this is y, this is z. Okay, this is 1. So 1, 0, 0 is right here. Is right here. That is 1, 0, 0. And this is 0, 1, 0. And of course, this is 0, 0, 1. All, you know, they are mutually orthogonal, right? They are mutually orthogonal. So, you know, vectors in the standard basics are unit vector. Unit vector means they have norms 1 and they are orthogonal, right? Let's say this is u, this is v, this is w. So, you know, they are orthogonal with each other. That is very important. And that's the purpose of this chapter. We will study how to get an orthogonal basics, and not only how to get an orthonormal basics, means basics with all vectors of norm 1, and all vectors are mutually orthogonal. All right. All right, so let's consider the following example. Suppose you have a vector, okay? Suppose you have a vector. You want to determine, you know, the space, the subspace, which is orthogonal to U. In this situation, right, we have R2, right? But, you know, I mentioned several times, when we're talking about vectors, we might think about points. So if you have one point here, you connect that with the origin, right? You connect that with the origin. So you have some straight line. Then you have right to determine the subspace. Whatever in here, if you are considering R2, the subspace is just a straight line, which is passed through the origin. But if you are talking about R3, the subspace orthogonal to V would be a plane. Don't forget about that. Okay? So we don't care too much about that. You know, you just look at this picture like, yeah, you have U, and then you want to determine the subspace right here, whatever you have, which is orthogonal to U. That is the problem. Okay, so let's say we have vector U equal to 4, 2, right? We want, and of course this is in R2. So basically we need to find a straight line which is orthogonal to this vector. All right, so let's say find all vectors that are orthogonal to V or to U. Okay, so we use the definition. Suppose I have x and y, right? Is, you know, some vector v, x and y, we need to determine. And v is orthogonal to u, means dot product of u and v is equal to 0. So let's find dot product of u and v. That is x, y, and here dot product with 4 and 2, right? And we set this equal to 0. We calculate dot product, that is 4x plus 2y equal to 0. So from here you can see that is y equal to negative 2x. So that means, you know, all points on the straight line y equal to negative 2x will be orthogonal to the point 4, 2. Suppose this is 4, this is 2, right? So this is 4, 2. Point right here, and we have, you know, vector right here. And we can plot the straight line y equal to negative 2x. Where's that? Pass through the origin. When x equal to 1, y equal to negative 2. So this is 2, this is 1, negative 2 is right here, right? Sometime. Yes, you see. So that is the subspace. That is the subspace, you know, orthogonal to the given vector. That is the subspace. Don't forget that. That is a subspace. That is really important, you know. That is subspace. And I hope you still remember, right? Not every straight line in R2 will be subspace of R2. Only straight lines that pass through the origin will be subspaces. Okay, don't forget about it. All right. We have a couple of inequalities in this section. Okay. Let me tell you about that, and we just do a couple of examples, and then we can finish this lecture. The first inequality, that is the triangle. You know, it's obvious. So if you have, you know, two vectors u, okay, and that is vector v, so that is u plus v. Or you can write here, if this is the origin, so the v look like this, okay, this is the v, so we have parallelogram law, that is the v, and the sum of u and v is just, you know, the diagonal, right? And it says the length of the diagonal is less than or equal to the length of u plus the length of v. That's obvious. Okay. Another one, that is Pythagorean theorem. The Pythagorean theorem says if we have two vectors, that is u, this is v, right? And suppose that they are orthogonal, means the angle between them is pi over 2. Then that is the sum of u and v. Is that correct? And the length of the sum of u and v square is equal to the length of u square plus the length of v square. It's also obvious because if you're talking about the length of u and v, so in this situation, in this situation we have rectangular, right? Rectangular. So the length of u and v, that is just equal to the length of this guy. The length of this guy. Is that correct? So, but the square of the length of this guy is equal to the square of u and the square of v. So that's why we have this identity. One more important inequality, which is called Cauchy Schwarz inequality. Cauchy Schwarz inequality was inequality. This comes from the formula of cosine. It says absolute value of dot product between two vectors, just absolute, less than or equal to the norm of v of u product with the norm of v. This is also obvious. Why? Because you have cosine of theta, where theta is the angle between u and v, is just equal to u times v divided by u, norm of u and norm of v. And the angle is always, the cosine is always between -1 and 1. Between -1 and 1. So from here, if you apply absolute value to both sides, so you get uv over u and v in here, less than or equal to 1, greater than or equal to -1. And then from this, you get this inequality. It looks very simple, but I tell you, this is very nice and important inequality, right? All right, let's consider some examples. Let's verify the Cauchy Schwarz inequality. Okay. Verify the Cauchy Schwarz inequality for the following vector. For the following vectors, u is 1, -1, and 3, and v is 2, 0, and -1. Just verify that the inequality should be true. But try to just try to convince that actually that is true. Okay, so let's consider the product of u and v. That is 1 times 2 plus -1 times 0 plus 3 times -1. So you can find that is 2 minus 3, which is -1. And then you can find the norm of v, norm of u, that is square root of 1 plus -1 square. Okay, let's write squaring here, and then 3 square, which is square root of 11. And the norm of v is 2 square plus 0 square plus 1 square is square root of 5. And the absolute of u and v, the product of u and v is just 1. Of course, this is less than or equal to square root of 11 times square root of 5, which is 55. So, that is pretty easy. Okay? All right, so let's do one more example before we finish this lecture. Let's work on Pythagorean theorem, on the angle, and on the triangle inequalities. Okay, Let me find an example from the homework, and then we'll do that. Example. Okay, let u is 2, -2, and 1. V is 2, -1, and -6. First, let's find the distance between u and v. Okay. The second, let's find the angle theta. So that means you know phi cosine. And the third one, determine. Oh, from here we can see if u and v are orthogonal or not. Okay. All right. I think that is enough for this. So the distance between u and v is square root of 2 minus 2 square plus -1 minus -2 square plus -6 minus 1 square. So you know we have to be very careful with this because when you subtract them, right, subtract with the minus. So don't forget, we need to write in parentheses, otherwise we can get wrong. So this is 0, this is 9, this is 49, and then you apply square root, you sum them up, you get square root of 58. Okay, and the cosine, you take dot product of u and v and divide by the norm of u, divide by the norm of v. So the dot product of u and v is 2 times 2 plus -2 times -1, and then plus 1 times -6. The norm of u, 2 square plus -2 square plus 1. The norm of v, 2 square plus -1 square plus -6 square. And what is that? We have 2 plus 2 is 4, 4 minus 6 is -2. And in here you have square root of 8. I have 9 here, which is very nice. The second one, I have 8. 4 plus 1 is 9. 9 plus 36. 9 plus 36 is 45. 45 in here. Okay, so you know you can simplify that whatever you want, but we will have. Okay, let's simplify that as I have said. So I have -2. I have 3 times 3 square root of 5, right? Or -2 over 9 square root of 5. From here you can find theta equal to a cosine of -2 over 9 over square root of 5. So we finished section 5.1 on the length and the distance between two vectors. Of course, these two vectors are not orthogonal, right? Because dot product is not 0. So in the next sections, if you have two vectors which are not orthogonal, okay, so in this case we don't have that. We will learn how to determine. A vector, let's say W in here, which is orthogonal to U. Okay, so I will do that in the next lecture. Thank you for watching, and I hope that you'll be safe. If you have any questions, please send me an email. Okay, bye-bye.